to look at simplifying surds. Now, in order to understand what a surd is basically a number involving a square root. So, for example, the square root of 2, the square root of 5, and the square root of 11 are all examples of surds. These are surds that do not have an integer as a square root, whereas something like the root of 9, which we know is 3, does have an integer square root. So the first thing we need to look at is the basic rules of surds. If I multiply the square root of x by the square root of y, that is the same as multiplying x by y and then taking the square root of those. Similarly, there is a division rule where if I divide the square root of x by the square root of y, that is the same as dividing x by y and then square rooting. The last rule is that if I do the square root of x multiplied by the square root of x, I end up with, using the rule above, the square root of x squared. And as squares, rooting and squaring are inverse operations, this means that I end up with x. So we're going to look at simplifying root 8. Now, because surds involve square roots, we are looking to find square factors of the number underneath the square root. We know that 4 times 2 is 8. Using the rule we've just looked at, the square root of 4 times the square root of 2 is equivalent to the square root of 4 times 2. The square root of 4 is 2. So this means that this is 2 multiplied by root 2. There is no square number other than 1 that goes into this 2 here. So this surd is written in its simplest form. So the trick is to work out what square numbers divide the number under the square root sign. Root 18 can be simplified to 9 times 2 all square rooted using our third rules. Square root of 9 times the square root of 2. We know the square root of 9 is 3, and we end up with 3 square root of 2. So root 18 is equal to 3 root 2. It may be that you have to take out more than one square factor, and you can do this in stages. If we take, for example, the number 1,200, we know that this is 100 times 12. So that tells us that we've got 10 root 12. However, 12 can be divided by 4, which is a square number, so we can write this as 4 times 3. Now, 10 times the root 4 times 3 can be simplified to 10 times the root of 4 times the root of 3. We know that 10 times the root of 4, which is 2, times by 3, can be multiplied and simplified as 20 root 3. It doesn't matter whether we took out the square root of 4 first or the square root of 100, you will end up with the same answer. So you need to look very carefully that this number at the end cannot be divided by a square number other than 1. A common example of how you might have to simplify surds is to incorporate expanding brackets. So if we look at 2 plus root 3 multiplied by 1 plus root 3. I'm going to do 2 examples, one using the box method for multiplying out and one using the just the brackets themselves. So if I do 2 times 1, I get 2. If I do 2 times root 3, I end up with 2 root 3. I then do 1 times root 3, which is root 3, and then I have to do root 3 multiplied by root 3. I can now simplify this. I've got 2 plus this root 3 and this root 3 can be combined to make 3 root 3. And I know that root 3 times root 3 here is equal to 3. So 2 plus 3 is 5. 5 plus 3, root 3, is that bracket expanded and simplified. If I now take 5, take away root 6, multiplied by 7 plus 2 root 6. I'm going to use a 2 by 2 grid method to expand this bracket. 5, take away root 6, 7 plus 2 root 6. It's important to keep the signs in. 5 times 7 is 35. 7 times negative root 6 is negative 7 root 6. 5 times 2 root 6 is 10 root 6, and that's positive. And then I end up with negative root 6 times 2 root 6, which gives you negative 2 root 6 times root 6, which we know is equal to negative 2 times 6, which gives you negative 12. So we now combine together, so we end up with 35 take away 12 using these. So 35 take away 12 is 23. And then for the root 6, I've got 10 root 6 take away 7 root 6, which gives me positive 3 root 6. So that we end up with 23 plus 3 root 6. So expanding brackets with surds is exactly the same as expanding brackets with normal letters and numbers. You just have to make sure you collect together the like surd terms and multiply and simplify surds correctly.